When you look at a modern propeller plane, you are seeing a design that has been around since the dawn of flight. But if you listen to the engine, you'll notice a high-pitched whine that sounds more like a fighter jet. That's because many of these aircraft are actually powered by jet engines. These are called turboprops. They replace the heavy pistons found in older planes with a light, powerful jet turbine. This allows a plane to keep the efficiency of a propeller while gaining the massive strength of a jet. If you want to learn more about how the world's most impressive machines actually work, hit the like button and subscribe to join us on this aviation journey. Learning how these engines work connects the physics of classic propeller flight to the high-speed technology used by the world's fastest jets. The fundamental mechanism is actually quite simple. Think of a pinwheel. When you blow air onto the blades, the force of your breath makes the wheel spin. A turboprop works the same way. Inside the engine, a jet creates a massive, continuous windstorm of hot, expanding air. This wind rushes past internal blades, forcing them to spin and turn the front propeller. Standard jets use exhaust to push forward, but this engine catches that wind to create circular movement, turning fiery exhaust into mechanical rotation. We can understand how this works by looking at the engine as 4 separate sections, each with its own job to do. First is the power section, the heart of the jet. It pulls in outside air, squeezes it, mixes it with fuel, and lights it on fire, creating a high-pressure stream of hot gas. As that gas spins the internal blades, it creates massive twisting force. To move that force forward, we use the power link. This heavy-duty connector captures the engine's rotation and carries it to the front. This jet energy is raw and violent. With such intense spinning, we can't bolt the propeller directly to the engine core without everything shaking apart. This brings us to a major engineering hurdle. The jet core is spinning at tens of thousands of rounds per minute. If the propeller blades moved that fast, they would hit the speed of sound and likely shatter from the stress. To solve this, the energy enters the speed reducer. This works exactly like the gears on a multi-speed bicycle. A small, fast gear from the engine turns a much larger, slower gear connected to the propeller. This trades extreme speed for steady, usable power. Tucked underneath all this is the support system. These smaller gears use the engine's rotation to power the plane's lights, radios, and flight instruments, keeping them all in sync with the engine. The front half of the engine acts as a translator. It takes the frantic energy of a jet and tames it into a controlled spin that a pilot can actually use to fly. So, what happens to all that hot exhaust gas once it has finished spinning the internal blades? Even after the engine has taken most of the energy to turn the propeller, the physical air still has to leave the system. It shoots out of the exhaust pipes at the back of the engine. This escaping air provides a small amount of extra push. While the propeller does most of the work to pull the plane forward, the exhaust provides a final boost from the rear. Aircraft designers have 2 different ways to connect the spinning engine to the propeller. Both methods work, but they use very different philosophies. The first is the physical connection. A solid metal shaft locks the jet core directly to the gearbox. When the engine turns, the propeller turns at the exact same time. The second is the air connection. Like 2 fans facing each other, turning one on creates wind that spins the second. There's no metal shaft. The engine simply blows a powerful stream of air across a gap to spin a separate turbine. Engineers decide which system to use based on the plane's total weight and the space available inside the wing or the engine cover. Whether using a metal shaft or airstream, the goal is the same: finding the most efficient way to turn expanding mass into motion. Let's follow the entire process as it happens in real time. Air enters and ignites in the center. This expanding fire spins the rear turbine blades. The power link carries this rotation forward to the gearbox, slowing the speed to turn the propeller, while exhaust gas shoots out the back for extra thrust. These 4 systems work in perfect harmony to achieve one result: turning a continuous flame into steady flight. The next time you see a propeller plane at the airport, you'll know you're looking at more than just a set of spinning blades. You're looking at a high-tech jet engine. Aviation can seem like a world of impossible math and complex machines, but even the most advanced engines are built on simple, understandable concepts. Modern engineering allows us to take the violent energy of a jet and use it to power a simple propeller, turning the power of fire into a daily reality of flight. Thanks for watching. Keep learning and keep looking up.